What's up, y'all? Last time we looked at graphing polar coordinates and converting between polar and rectangular coordinates. Today we're going to look at actually graphing polars, and we're going to focus on circles and lines today. So you do need to be aware with these. I'll give you something uh, like r equals 3. And if you have a radius of 3, this is just going to produce a circle at the origin that's centered at the origin. So it's going to look something like this. We would go out 3. That's our radius. Our radius is 3. And then we need to consider what is the form, what is the rectangular form in terms of x and y for this equation, which we looked at on the very first day. That looks like this, where we have our h and k is our center, and our radius is given to us right here. So if I'm going to plug this in, if I'm going to plug what I know in, my center, if I'm centered at the origin, h and k are both 0, and if I'm giving you r equals 3, then r squared is 9. So this would be our rectangular form of this equation. So you need to be able to graph that and then write the rectangular form of that equation. Here, if I give you and I ask you to graph theta equals 60 degrees, we're just simply going to graph that, but this is going to go through the other side too. So this is a line, and so we need to think about what does the equation of the line look like. That is y equals mx plus b. So we're going to try to figure out what the other stuff is that's going on here. So I will tell you that for the purpose of this unit, our line will always go through the origin, so b will always be 0. So we're just trying to find our slope. Our slope is still our change in y over change in x, but with angles, we use the tangent. So tangent is y over x. So we would say we can go ahead and write y equals mx. And then to find our slope, we're going to say, well, that's just the tangent of theta. Well, what is theta? Theta is 60 degrees. So then the tangent of 60 degrees, sorry. So what we did, we found our slope here. We found our m, so I'm plugging this back in. The tangent of 60 degrees is square root of 3. So now that is what my equation of my line is. Y equals square root of 3 times x. All right, here we have a circle that is on the x-axis. Anytime you see r equals cosine, you will have a circle along the x-axis. And think about, to remember that, maybe think about that because cosine is talking about x. So the diameter is the coefficient in front of the cosine, the diameter of the circle. And from the origin, we count over on the x-axis. So we're going to go from the x-axis, the length of the diameter. So I'm going to go over from here, go out 5, and I'm going to try to put my center in the middle, and that point's 2.5, comma 0. And then we're going to kind of eyeball the rest of it approximately so we can draw our circle kind of like this. So this would be a circle on the x-axis. And then our center is 2.5, comma 0. So in rectangular form, our radius is 2.5. We can see that here. So now if I plug this in, this is a circle, right? So I'm going to use that for my equation of the circle. I have x minus 2.5, my h squared plus y squared. And if I square 2.5, I get 6.25. And this would be my rectangular form. All right, let's look at the circle on the y-axis. So similar to the cosine, anytime you see r sine, you will have a circle on the y-axis because sine is y. The diameter is still the same, what's in front of sine. But from the origin, because my diameter is negative, we're going to go the other direction. So I'm not going to go up, I'm going to go down. So I'm going to start from the center right here, and I'm going to count down 4. And then I'm going to kind of roughly sketch and then label those points because that's going to help me to sketch my equation of my circle or to write my equation of the circle. And then I'm just going to kind of go out a little bit so I can get a nice little circle like that. I can see that my radius is 2, and my h and k are 0, -2. So I can plug all of this stuff into my equation of a circle, and I get x squared plus y plus 2 squared equals 4. So vertical lines have secants. That's our secant ones. So when we see secant or cosecant, we need to know that these will create vertical or horizontal lines. So secant is going to be a vertical line. The reciprocal of secant is cosine. Cosine is x. So the coefficient in front of the secant will go through that x value. So you really just need to be looking at, you need to understand that secant is a vertical line and look at the number in front of it and then go through the x value of -3. So if we mark off where -3 is, that's going to be right here. That is our -3 secant of theta. What would that look like on a rectangular form? That's going through x equals -3. So rectangular form is just using x and y instead of r and theta. So that's what our equation would be, x equals -3. Cosecant is the reciprocal to sine, which has to do with y. So similarly, if secant was going through an x value, cosecant is going to go through a y value. And our 5 is positive, so we're going to go up 5. And we're going to draw a line through the y value of 5. And then our equation is just y equals 5. And that's all we have on this. We'll talk about something else next class.